functions, and inverse trig functions need a little bit of explaining. The first thing I want to do is talk about regular trig functions, because we've never talked about the domain and the range of a regular trig function. But the domain for sine is all real numbers, but anything you put in for the sine of x, your smallest value will be -1 and your biggest value will be +1. So anything you plug in, your range is going to be between -1 and 1, and those are included. Same thing with cosine. I can plug in anything. My range is going to be between -1 and 1 with those values included. And then the tangent of x, if you remember when we were filling out the chart, we had values that were undefined. So x couldn't be 90 degrees or -90 degrees, but anything we put in, we're going to get a real number. And you'll probably see this more when we graph later on. But what I need to talk about is an inverse function. So in order for a function to have an inverse, it's got to be 1 to 1. So this can only make sense, though, if you remember, if we were looking for exact trig values, the exact trig value of 30 degrees, the sine of 30 degrees, for example, is 1/2. Well, the sine of 150 degrees is 1/2 as well. That means that it's not 1 to 1. That means that for every y, there's not exactly one x. So they had to go in and restrict the domain. All that means to you is that if I'm restricting the domain, then I'm going to get these values out. When I take the inverse of that, or when I swap the domain and the range like I would do in an inverse, I swap the x and the y. That means that the cosine of x, its inverse, is always going to be between -π/2 and π/2. Or what you need to remember is that the sine of x, I need one positive value and one negative value. So I'm going to get my positive value from quadrant 1. I'm going to get my negative value from quadrant 4. For cosine, same thing. I need a positive value and a negative value. So I'm going to use quadrant 1. I can't use quadrant 4 for cosine, though, because cosine is positive in the fourth quadrant. So I'm going to use quadrant 2. And then tangent x and sine of x are going to be the same. So quadrant 1 and quadrant 4 gives me a positive value and one negative value. So this, when I restrict my domain, then I get my inverse. I can find an inverse of these trig functions, which just means what I just told you. So if I'm looking at sine of x, if I got a positive, I'm getting it from quadrant 1. If I got a negative, I'm getting it from quadrant 4. For cosine of x, my positive value is going to be from quadrant 1, my negative value is going to be from quadrant 2. Tangent, quadrant 1, quadrant 4. Alright, so I'm going to move on. Now, the biggest thing with this is the notation. So notice that I've got sine to this little -1 thing. This does not mean a negative exponent. I don't take it and put 1 over the sine of x. This actually is just the notation we use for inverse trig functions, and on your calculator you'll see that, or you'll see arc sine. Either one of those notations, and I think the book interchanges, so sometimes you'll see that, sometimes you'll see that. Alright, so that's the notation, but what you need to understand is what this is asking for. Alright, so in regular trig functions, I would give you the sine of some angle and ask for the exact value. The inverse of that, I'm going the other way with it. So I'm looking for the sine of some value. I want to know what the angle is. Because this is very important that you understand that if I'm looking for an inverse trig function, I am looking for an angle. So what this is asking me for is the sine of what angle is the square root of 3/2. Well, this exact value is positive, so my angle is going to be coming out of quadrant 1. What sine of what angle is the square root of 3/2? Well, that's 60 degrees. So there's my answer. The inverse of the sine of the square root of 3/2 is 60 degrees. Okay, let's do the negative. Alright, so I'm looking for the sine of what angle is negative square root 3/2. Well, we've already talked about that my range has to come from the first quadrant or the fourth quadrant. If it's negative, it comes from the fourth quadrant. So I'm looking at this negative exact value. So I'm looking for my angle coming out of the fourth quadrant. This is really easy to do because you're just going to make it negative. Okay. Cosine's a little bit trickier because if I am looking for the cosine of what angle is the square root of 2 over 2, well, we know that's 45 degrees, so the inverse of this is 45 degrees. All right. However, if I change this up and I say, all right, let's make this negative. Well, remember that I can't pull my negative value from the fourth quadrant because cosine is positive in the fourth quadrant. So my negative value comes from quadrant 2 with cosine. Now, this is what you've got to think about. So you've got to think about what angle in quadrant 2 gives me a reference angle for 45 degrees. Well, if I'm going to try to figure that out, I'm just going back to this x-axis thing, and I'm doing 180 minus 45. So 180 minus 45. And so this is going to equal 135 degrees. Okay? Let's keep going. All right, so 17, and this is all from 6.4. 17, it asks me to find theta, and I know those are always blurry because I write them so little with a big fat marker. But if I'm looking for theta, what you need to pop in your head is if I'm looking for theta, if I'm looking for an angle, I've got to use my inverse trig function. That's what I'm doing. I'm not looking for an exact value. I'm looking for the angle that gives me that exact value. Okay, so if I'm looking at this and I'm thinking, all right, how am I going to find this angle? Think about what you're given. I'm given my opposite and I'm given my hypotenuse, which means that the sine let me rewrite that so you'll understand it a little better. So the sine of theta is going to equal 6 over 10. All right, so I've got opposite over hypotenuse. Now, if I'm looking for this angle, I've got to use my inverse trig function. So the sine, there's my inverse notation. I'm looking for the sine of what angle is 6 over 10. Okay, so find this button on your calculator. You're probably going to have to use your second button or whatever, and put that in parentheses, and you'll see that when you plug that in, it's about 36.9 degrees. Okay, let's do another one. Cosine of theta equals 3 over 4. Same thing. I'm looking for an angle, so I'm going to use my inverse trig function. All right, the cosine of what angle is 3 over 4? When I plug that in my calculator, and I should keep making sure I use approximations there because we are approximating these, it's 41.4 degrees. Okay, this one looks a little bit trickier, but it's not if you understand what they're asking for. Okay, so what is this asking for? Well, this right here tells me that I want an angle, or theta, right? This is saying the sine of what angle is 2 over 3. And it wants to know the cotangent of that angle, all right? So the easiest way to do that, always just drop a right triangle, label your theta, all right? This is what this is asking for. So the sine of what angle is 2 over 3? Well, opposite over hypotenuse. So there's my 2, there's my 3. I want to find this third side, so I'm going to use the Pythagorean theorem to do that. So I know that 2 squared plus whatever that third side is going to equal 3 squared. So x squared is going to equal 9 minus 4, which is 5. So x is going to equal the square root of 5. So I know that third side is the square root of 5. All right. Now it's asking me for the cotangent of that angle. All right. So I used my inverse relationship to find what that angle was. I know that's what that's asking for. It's asking for the angle. And if I were looking for the cotangent of theta, the cotangent is the reciprocal of tangent. Tangent is opposite over adjacent, so cotangent is adjacent over opposite. So I've got adjacent over opposite, and that's my answer. Alright, one more, and this is actually a word problem, and the good thing about this word problem in particular is that they drew the picture for you, and the picture in the book, of course, is a lot fancier than what I just sketched out here. But anytime you do a word problem, make sure you draw a picture if it's not given to you. This one was given to me, and all it's asking for is the height. So you can read the problem and look at the picture, but what they're asking for is this height value right here. And if I'm looking for that, that means that I'm going to use my opposite and my adjacent. So I'm going to use the tangent of theta is going to equal my height, or the opposite over my adjacent. And if they want to know the height, that means they want h by itself, or you to solve that for h. So when I cross multiply here, I know that h equals 2 times the tangent of theta. Alright, I'm doing the same thing except they want theta. So I'm looking at this and going, alright, instead of isolating h, I'm going to isolate theta. Well, how do I isolate theta? If I'm looking for theta, I have to use the inverse trig function. This just means that the tangent, the inverse tangent, or the tangent of what angle, is h over